Okay, 7.2 in the review. This is a huge section, okay? Probably one of the core things we did this semester was solving equations. We did a lot at the beginning, but then it came back several times in the semester. So what this section is, every time we solved an equation, and we solved many different kinds, they're all going to show up on your test, okay? So we started out solving equations by factoring, okay? So if I look at something like this, 2x squared equal 4x. Okay, the best thing I want is I want to solve something set equal to 0. So 2x squared minus 4x equals 0. Then I say, is there anything I can factor? Yes, you can factor out a 2x, and you get this expression, and then you set each factor equal to 0. If 2x is equal to 0, or x minus 2 is equal to 0, your solution is 0 and 2. Okay, so this is just basic factoring to solve an equation. So I look at the one over here. So you've got to be really solid with your factoring rules. When I look at this, this looks like the difference of two squares. Okay, so I want to factor this. So that is what? 2x minus 6, 2x plus 6. This is one way to do that, equals 0. Set each factor equal to 0. 2x minus 6 equal to 0. 2x equals 6, or x equals 3. 2x plus 6 equals 0. 2x equal minus 6, or x equal minus 3. So your answer is 3 or minus 3, okay? Now what you see here is I did and the other way of doing it is factor out a common factor to begin with, and then difference of squares, but either way you get to the same answer. So you got to be really solid on factoring. You got to be able to look at something like this and like, oh, I got to factor that polynomial in order to solve it. Two numbers that multiply to 8, add to 6, that's 2 and 4. So you factor it, you get a solution, okay? So every factoring method we have ties into solving equations. So get your equation equal to 0, and then you realize, oh, I need two numbers that multiply to 30 and add to 17. Then you proceed with factoring. This one, I've got 4 terms. My only hope is to solve this thing by grouping, okay? So you get a solution from there. So I'll work some examples when we get to the assignment here. But let's spend a little bit more time on things that maybe did not stay with us, like those factoring methods. Solving something that has a radical, okay? If something has a radical, then what you want to do, you want to isolate that on one side of the equation, and then you do something to the equation, both sides, to make that go away. Keeping in mind, if you ever square both sides of an equation, you've got to check your answer to make sure it's valid. So let's just look at this one, okay? My goal is to have this radical all by itself. Well, good news, it's all by itself. The way to solve this problem now, so is 5 minus x equal x plus 1, is I'm going to square both sides of that equation. The reason I do that is on the left side, it gets very simple in a hurry. That's what happens when you square the square root of 5x. On the right side, you get x plus 1 squared, okay? I hesitate to write this down, but this is not x squared plus 1 squared. You should know better than that, okay? That's going to be a big drawback to being able to solve anything if you go to that solution. So this is 5 minus x equal x plus 1 times x plus 1. Then this is 5 minus x equal x squared plus x plus 1. Or 5 minus x equal x squared plus 2x plus 1. Now, I want to solve that. Best thing I could do is set that thing equal to 0. So I could subtract 5 from both sides. I could add x to both sides, and I would get 0 equal x squared plus 3x minus 4. How do I solve that? To solve that, I need two numbers that multiply to -4, add to +3. That's going to be a -1 and a +4. So my answer is x minus 1, x plus 4 equals 0, which tells me that x is equal to 1 or -4. Okay. Now, you're not done until you check your answers. Okay. I have to go back to my original and make sure that these answers are valid. So if I've got the original was the square root of 5 minus x equal x plus 1. Let's check x equal 1. So if x is equal to 1, does the square root of 5 minus 1 equal 1 plus 1? Does the square root of 4 equal 2? That's a yes. Let's check with the negative 4. So does the square root of 5 minus negative 4 equal negative 4 plus 1? Does the square root of 9 equal negative 3? Does 3 equal negative 3? That answer is no. Okay, so your only answer here is x equal 1. Okay, so very important, when you square both sides of an equation, you're going to have to go check your answer to make sure it's valid. If I look at this one, the cube root, what I need to do to this is I need to cube both sides of the equation. So when I cube the left side, I get x plus 1. 4 cubed, that's 4 times 4 times 4, that's 64. Solve that for x. X is equal to 63. I did not square both sides of the equation, so I'm good to not check the answer on that one. Looking at the next one, I've got a square root. My solution here is square both sides. When I square the left, I get 2x minus 1. When I square the right, I get 36. So 2x is equal to 37. X is equal to 37 over 2. Now I square both sides of the equation. I really only need to check it when I get 2 answers, but I can double check this for sure just to make sure it's a valid answer. So if I had 2 times 37 over 2 minus 1 equals 6, this is the square root of 37 minus 1 equals 6. Square root of 36 equals 6. That is a true statement. My answer is 37 over 2. Now, we moved into solving equations that have integer and rational exponents. Okay, the key here, whatever you see that's raised to a power, get it by itself. Okay, so in this equation, I could write x plus 1 cubed is equal to 7 plus 1. I'm moving that 1 to the other side of the equation. X plus 1 cubed equal 8. Now I want to take the cube root, or raise everything to the 1/3 power. On the left, I get x plus 1 equal 8 to the 1/3. What does 8 to the 1/3 mean? That means the cube root of 8. So this is x plus 1 equal 2, or x equal 1. So again, the key is isolate whatever expression has the exponent and then raise the entire equation to the appropriate power. If I look at this one that you see right here, what I need to be by itself is this. Excuse me. I need this x minus 3 to the 1/4 to be all by itself. Okay, the way I'm going to get that to happen, first of all, let's subtract 4 from both sides. So I get 2 x minus 3 to the 1/4 is equal to 4. Now to get it by itself, I need to divide both sides by 2. And I get x minus 3 to the 1/4 equal 2. Now I'm going to raise everything to the 4th power. On the left, I get x minus 3 equal 2 to the 4th. X minus 3 equals 16. X equal 19. If I look at this one over here, isolate that x to the 3/4. X to the 3/4 is equal to 9 minus 1, or 8. Now I need to raise this equation to the 4/3 power. So I get x on the left is equal to 8 to the 4/3. This is the cube root of 8 raised to the 4th power. So this tells me that x is equal to the cube root of 8 raised to the 4th power. That's 2 to the 4th, or 16. So x is equal to 16. Now there are a couple of special cases you want to take a very cautious look at. If I ever have something like x squared is -4, okay, this has no real solutions. You can't square a real number and get a negative number. So if you see anything like that, you know this has no real solutions. Now, but we have to take real caution is if I've got x to an even power is positive, I'm going to get two answers, okay? Or if I have x to a fraction, like an even number, like if I got something like x to the, 2/3 equal 4, anytime I've got an even in the top of that fraction, I'm going to have a plus or minus in my answer, okay? So let's take a few examples of those. So let's look at this one right here. So I've got x plus 3 to the 2/5 is negative 4. Let me do the one on the right first. X plus 1 to the 2/5 is equal to 4. So x plus 1 to the 2/5 equal 4. Since that is an even number, I'm going to have a plus or minus in my answer. Okay, so I'm going to raise everything to the 5/2 power, and I get x plus 1 equal plus or minus 4 to the 5/2. What does 5/2 mean? It means the square root of 4 raised to the 5th power. So this is x plus 1 equal, what's the square root of 4? That's 2, raised to the 5th power. So x plus 1 equal plus or minus 32. X equal negative 1 plus or minus 32. So x is equal to 31 or negative 33. Those are my two answers. Over here, when you see x plus 3 to the 2/5 equal negative 4, what you have to see here is that in this case, there's not going to be a solution because I've got an even numerator in my exponent, but it's a negative number, okay? If I were to try to do the same process of what I did a moment ago, I would have x plus 3, when I raise it to the 5/2 power, is plus or minus, and that's what, negative 4 to the 5/2, okay? That would mean I'm taking the square root of negative 4 and raising it to the 5th power. There is no real solution here, okay? So no real solution when you have an even exponent as an integer or the numerator of a fraction set equal to a negative number. Now from there, we moved into solving polynomials of higher degree, okay? So this should be a little bit fresher on your mind because we've done this more recently. So what we do is we start with polynomials, okay? We start with polynomials. You should be able to figure out what the possible rational roots are. It's the factors of 4, which you see right here, divided by the factors of 6. Okay, the factors of 4 are 1, 2, and 4. The factors of 6 are 1, 2, 3, and 6. So these are all the possible rational roots. So you start using those until you get 0 remainders, and that's how we will factor that. Now there were a couple of shortcuts. If the coefficients add up to be 0, then x minus 1 is a factor, or x equal negative 1. X minus 1 is a factor, x equal 1 is a solution. So in this case, 6 plus 13 is 19. 19 minus 3 is 16. 16 minus 12 is 4. 4 minus 4 is 0. Those coefficients add to 0. So I'm guaranteed that x minus 1 is a factor. So I can do synthetic division with 1, and I get a 0 remainder. Okay. Now I have to look and see what am I left with. And then I have to figure out, based on the rational roots, let's try roots until I get ones that factor. Okay, so this is a repetitive process. You're going to need to spend some time with this, but your goal is to take this polynomial that starts out as a 4th degree. I need to find 2 roots to get it down to a 2nd degree, and then I factor the 2nd degree polynomial. Okay, so we've done quite a bit of this. This was our biggest unit in polynomials. So we'll do a few examples of that in a moment. Other problems we had were solving equations where the exponent contained the variable, okay? So something like this, 2 to the x equal 4 to the x plus 1. My only hope of solving an equation like that right now is to get the same number on both sides raised to a power, okay? If I look at this, 4 is a power of 2. So I can rewrite this as 2 to the x equal 2 squared to the x plus 1, okay? So now I've got this to where I've got the same number on both sides. These exponents have to be equal to each other. So x has to equal 2, x plus 1, which means x has to equal 2x plus 2. And so if I subtract, we'll subtract 2 from both sides. So I get x minus 2 equal 2x. Subtract x from both sides, and I get negative 2 equals x. So x equals negative 2 in this case. Okay? Now some of these got a little bit more complicated, but you can handle that. So if I look at something like this, 1/2 to the 2x equal 1/8 to the x plus 1. So what I can look at it is this is 1/2 to the 2x is equal to 1/2 cubed. That's what 1/8 is, okay, to the x plus 1. Now I've got the same number on both sides raised to a power. So I know that 2x has to equal 3x plus 3. That means that minus x has to equal 3, or x equals minus 3 is a solution to that. One more here. 4 to the x plus 1 equal 1/2 to the x. You need to be very comfortable in recognizing, say, powers of 2. So on the left, I think people recognize that's 2 squared to the x plus 1. But on the right, this is 2 to the negative 1 raised to the x. So I get 2 to the 2x plus 2 equal 2 to the negative x. Now my exponents can be set equal to each other. 2x plus 2 equal negative x. That means that 3x equal negative 2, or x equals negative 2/3. Okay, so people found this a little bit confusing, but this is toward the end of the semester, so you should be okay with that. So here are some problems to work with solving equations and involving some exponents. Evaluate this without a calculator. Negative 5 squared. The only thing being squared is the 5, okay, not the negative. Okay, so this don't interpret this as this. You're adding something to the problem. Okay, this is a negative number, so this is negative 25. Okay, the next one, what's being squared, is the negative 5. This is negative 5 times negative 5. This number is positive 25. 5 to the negative 2, the way we handle negative exponents, wherever we find them, numerator or denominator, we make them positive by moving them to the other location. Okay, so this is a negative exponent in the numerator. It becomes positive when it goes to the denominator. So this is 1/25. Okay. You look at the next one. This is 1/5 to the negative 2 power. Okay, so if I look at this, this is 1 to the negative 2 over 5 to the negative 2. These negative exponents become positive if they move to a different location. So if the 5 moves to the top, it's a positive. The 1 moves to the bottom, it's a positive exponent. This is 25. Okay, simplifying. Okay, working with expressions with exponents, positive and negative, trying to simplify. Okay, so in this case, I've got, it's one of the best things people try to do is to move the exponents to make them positive. So if I do that, this becomes y cubed on the top of this fraction, and then that x to the 4th times 2, okay, times y to the 4th. So all the negative exponents move to make them positive, and so now you've got y to the 7th over 2x to the 4th. Looking at the next problem, so you've got, in this case, 2x to the negative 4th over x to the negative 4th, y to the negative 1. So if you want to make everything positive, this is, I can move that x to the negative 4th down here, and then on the bottom, I've got x to the 4th, it moves up, and you also got a y, okay? So x to the 4th divided by x to the 4th, that's just 1. this answer is simply 2y. Next one, I've got negative exponents and I've got things that are being squared. I can go ahead and rewrite this as, if you look at it, I can say this is, move that x to the bottom, so this is x. You've got a y up top. On the bottom, I've got that y to the negative 1. Let's move that up top, and you've got an x. So it's this squared. So you've got y squared over x squared squared. This is y to the 4th divided by x to the 4th. Now let's solve some equation. Here I have a power equation, okay? 2/3 to the x equal 4/9 to the negative x plus 1. So 2 over 3 to the x. What I'm looking for is, can I write 2/3 and 4/9 in terms of a common number? Well, I'm in luck because 4 is 2 squared and 9 is 3 squared. So I can write this as, this is 2/3 squared to the negative x plus 1. And now I've got the exponents can be set equal to each other. X equal 2 to the negative x plus 1. That tells me x equals negative 2x plus 2. So this gives me what? 3x equal 2, or x equal 2/3. Okay, the next one, solving this. This goes back to, that's a quadratic, okay? To solve a quadratic, you have to be able to factor a quadratic. So I need two numbers that multiply to negative 72 and add to negative 6, okay? So what are factors of 72? That's 1 and 72. That's 2 and 36. That's 3 and 24. That's 4 and 18. 5 doesn't go in there. That's 6 and 12. 7 does not divide into there. 8 and 9. And 9 and 8, and then I start to repeat myself, okay? Is there a way to combine these numbers and get a negative 6? That's going to happen right here. So if I had a 6 and a negative 12, that multiplies to negative 72, that adds to the negative 6. Rewrite this problem. This problem is now 8x squared plus 6x minus 12x minus 9 equals 0. Factor by grouping. What do these things have in common? It looks like they share a 2x. So that's 4x plus 3 minus, and it looks like between the 9 and the 12, I can factor out a 3. And that is 4x plus 3. And so my answer is 2x minus 3 times 4x plus 3 equals 0. So set these equal to 0, you get x is equal to 3/2 or negative 3/4. Those are your two solutions. So solving equations, set equal to 0, that's accomplished, that's good. Now what do I do? This is two numbers, it's either the difference of squares or greatest common factor. Let's factor out a 3 first, and then I get x squared minus 4 equals 0. Now I see it's the difference of squares. So 3, x minus 2, x plus 2 equals 0. Set each factor equal to 0, you get x is equal to 2 or negative 2. Next one, I've got a radical. My key is to get that radical all by itself. Square root of x plus 6 is going to be equal to 7 plus 1. Square root of x plus 6 equal 8. Now I will square both sides of this equation. And I get x plus 6 equals 64. X is equal to 64 minus 6. X is equal to 58. Two x to the 2/3 minus 1 equal 49. My goal is to get this x to the 2/3 all by itself. How do I do that? Add 1 to both sides. So 2x to the 2/3 equal 50. My goal, get x to the 2/3 by itself. How do I do that? Divide both sides by 2. So I get x to the 2/3 equal 25. Now, I notice that this is an even number at the top of this fraction. So when I solve this, I'm going to have a plus or minus in my answer. So I need to raise everything to the 3/2 power. That gives me x equal plus or minus 25 to the 3/2. What does 25 to the 3/2 means? It means the square root of 25 squared. So this is x equal, what's the square root of 25? That's 5. So this is plus or minus 5 cubed. So that is plus or minus 125. 4x squared equal minus 7. Divide both sides by 4. You get x squared equal negative 7/4. This has no real solutions. There is no real number that you can square and get a negative number. Okay? Number 7. To solve this, I would love for it to be equal to 0. So x squared plus 12x plus 27 equals 0. Now, I want to solve this by factoring. Are there numbers that multiply to 27 and add to 12? It looks like a 3 and a 9 will do that. This is x plus 3. X plus 9 equals 0. So x equal negative 3 and negative 9. Look at the next one. I got a cube root. It's already isolated. My key to solving this guy now is just going to be to cube both sides of this equation. When I cube both sides of this equation, I get 2x minus 3 equal 2 cubed. 2x minus 3 equals 8. 2x equal 11. X equal 11/2. The next one. My key to solving this equation is going to be to square both sides of the equation. That will give me x minus 4 squared equal x minus 2. When I square the left side, I'm going to get x squared minus 8x plus 16 equal x minus 2. I want this to be equal to 0. So I subtract x from both sides and I add 2. And that gives me x squared minus 9x plus 18 equals 0. I'm looking for two numbers that multiply to 18 and add to negative 9. Okay, so multiply to 18, add to negative 9. Those numbers are negative 6 and negative 3. So this is x minus 6, x minus 3 equals 0, which tells me x equals 6 or 3. Anytime you square both sides of an equation and you get two numbers, you need to check those numbers. So if I substitute both of these numbers in, so let's check x equals 6. So let's check x equals 6. That would give me 6 minus 4 equal the square root of 6 minus 2. Does 2 equal the square root of 4? That is yes. Let's check x equals 3. Does 3 minus 4 equal the square root of 3 minus 2? Does negative 1 equal the square root of 1? That is no. So you only have one answer here. That is x equals 6. Okay, solving the equation you see right here. X to the 4th minus 5x cubed plus 5x squared plus 5x minus 6 equals 0. 1, 2, 3, 4, 5 terms. There's no factoring method for this. This is the polynomials and synthetic division. So I've got to find a rational root to get this thing to solve. So let's look at this. What are some of my tricks? What if I add the coefficients? So 1 minus 5 plus 5 plus 5 minus 6, that's negative 4 plus 5, that's 1, plus 5 is 6. minus 6 is 0. Coefficients add to 0. I know that x minus 1 is a factor. X equal 1 is a root. Okay, so let's start with that. So 1 minus 5, 5, 5, negative 6. Okay, so at this point, I've factored it down to a cubic. So I know that f of x, excuse me, let's just back up here. I've factored this equation now to x minus 1, and then I've got what, x cubed minus 4x squared plus x plus 6 equals 0, okay? I've got to continue with my rational roots, okay? So my only possible rational roots are the factors of 6 divided by the factors of 1. So it's plus or minus, so plus or minus the factors of 6 over the factors of 1. These are just the factors of 6, 1, 2, 3, and 6, okay? So now I've just got to try other numbers. So I've got 1 to work, but I got to try negative 1, 2, negative 2, and try to get them to work. Now, if I look at this, if I add these numbers up, 6 plus 1 is 7, minus 4 is 3, plus 1 is 4. So these do not add to 0, so I cannot use 1 again. So let's just try negative 1. So let's try negative 1 on this factorization. So that gives me negative 1, negative 5. That gives me 5 plus 1 is 6. That's negative 6, and that is a 0. Okay, so it tells me that x plus 1 is a factor. So now I know that this is going to be x minus 1, x plus 1, and then if I read that bottom row, that's x squared minus 5x plus 6 equals 0. How do I factor that quadratic? What are numbers that multiply to 6 and add to negative 5? So numbers that multiply to 6 and add to negative 5, that would be a negative 2 and a negative 3. So this is x minus 1, x plus 1, x minus 2, x minus 3 equals 0. My solution is x is equal to 1, negative 1, 2, and 3. So 4 solutions. So that's a little bit involved, and that's sort of what we built a lot of our skills up, working up to be able to do something like that. I look at the next one. This is 4 terms. Let's see if it factors by grouping. Okay, so let's look at this. What can I factor out of the first 2 terms? It looks like x squared, and I'm left with x plus 3 minus, and it looks like x plus 3 equals 0. This is x squared minus 1 times x plus 3 equals 0. That's the difference of squares. X minus 1, x plus 1, x plus 3 equals 0. Therefore, x is equal to 1, negative 1, negative 3. X minus 1 cubed, my goal is to get that thing by itself. So x minus 3 cubed is equal to 15 minus 7. X minus 3 cubed equal 8. I've got it all isolated. Now I'm going to take the cube root, or raise everything to the 1/3 power. On the left, I get x minus 3. On the right, 8 to the 1/3, or cube root of 8. So this means x minus 3 equals 2. Therefore, x equal 5. Number 13, how do I solve this? Greatest common factor. It looks like there's an x squared, so that leaves me with 3x minus 1 equals 0. Set each factor equal to 0. If x squared is equal to 0, that means that x equals 0. If 3x minus 1 equals 0, that means x equal 1/3. Number 14, this is a power equation, okay? So my goal here is I want to get on both sides of the equation the same thing raised to a power. So I've got 3/4 to the x equals 16 over 9 to the x plus 1. Well, it looks like 16 is 4 squared and 9 is 3 squared. So this looks like 3/4 to the x equal 4/3 squared to the x plus 1. Now, I don't quite have the same number on both sides raised to a power, but I can take the reciprocal. I can write on the left side, this is 4/3 to the minus x equal 4/3 to the 2 times x plus 1. Now I've got the same number on both sides raised to a power. I can set those exponents equal to each other. Negative x equal 2x plus 1. Negative x equal 2x plus 2. And so if I solve this equation, I get negative 3x equal 2, or x equal negative 2/3. And some more solutions. Again, this is our biggest section. So there are problems for this section that are pulled from the very beginning of class and the very end of class. So this was a common thread through everything we did. So you're probably taking a break and you're not watching this video all the way through. Let's look at the next one. So this is a quadratic. I'm looking for two numbers that multiply to 60 and add to 17. If this is a final exam, my brain is mush at this point, and I don't really know that off the top of my head. So factors of 60, 1 and 60, 2 and 30, 3 and 15, okay? Oh no, sorry. That's what I meant about my brain being mush. 3 and 20, 4 and 15. So 5, look at this, 5 and 12, okay? And those are the numbers that are going to add to 16. So that I can rewrite this problem as 2x squared plus 5x plus 12x plus 30 equals 0. This is factor by grouping. X, 2x plus 5 plus, and it looks like 6, 2x plus 5 equals 0. So x plus 6 times 2x plus 5 equals 0. Set each of these factors equal to 0. X is equal to negative 6 or negative 5 halves. Next problem, I see this squared term. My goal is to isolate that. So x plus 1 squared equal 21 plus 4, which is just 25. So x plus 1 squared equal 25. Now my goal now is just to take the square root of both sides of that equation, keeping in mind, always remember when you've got something squared as a positive, equal positive number, your answer is going to have a plus or minus. So x plus 1 equal plus or minus, and that's going to be 25 to the 1/2, or the square root of 25. So x plus 1 equal plus or minus 5. So x equal negative 1 plus or minus 5. X is equal to 4 or negative 6. Next problem, x plus 3 to the 2/5 equal negative 7. So x plus 3 to the 2/5 equal negative 7. That's an even number as an exponent, set equal to a negative number. This has no real solution. If you didn't see that, you're going to raise everything to the 5/2 power, and you get x plus 3 equal negative 7 to the 5/2. That's telling you to take the square root of negative 7 and then raise it to the 5th power. The square root of negative 7 is not real, so there are no real solutions. Next one, these are perfect squares. So that is 5x minus 3 times 5x plus 3 equals 0. Set each of those factors equal to 0, and you get x is equal to 3/5 or x is equal to minus 3/5. And to end up this section, factoring a quadratic, are there two numbers that multiply to 7 and add to -8? I think a -1 and a -7 will do that for you. So this answer is x minus 1, x minus 7 equals 0. Therefore, x equal 1 or 7. Next problem. Let's set it equal to 0. X cubed plus x squared minus 12x equals 0. What you're always taught, if the greatest common factor works, do that first. I can factor out an x, and this is x squared plus x minus 12 equals 0. Inside that parentheses is a quadratic. It's asking me to look for two numbers that multiply to -12 and add to 1. So it looks like a 4 and a -3 would do that. So this is x plus 4, x minus 3 equals 0. Set each of those equal to 0. X is 0, minus 4, or positive 3. Okay, guys, this was a long section. And like I said, this is the heart of what we did, solving equations. We did it back in August, and we were doing that back in December, getting ready for the final. So a lot of things were thrown into this. You've never seen all of these problems jumbled together and thrown at you. So this is a key section to be able to master.